Welcome to the Foresight Tech Intro to Plumbing Codes class. There's the book we're using right here. The latest edition, the 2018 edition of the International Plumbing Code with the North Carolina Amendments Plumbing Code. And we're picking up with Chapter 6. So far, if you go back and take a look at the videos that we've gone over, it's Chapter 2 with definitions that we've covered. And you've taken a quiz on that. Chapter 3 with general regulations. Chapter 4 with the 4 F's, fixtures, faucets, and fixture fittings. Chapter 5 with water heaters. And then hopefully everybody's got their quiz completed for that chapter. And now we're into Chapter 6, which is water supply and distribution. It wouldn't hurt just to pop out those, just kind of review back over the material, flipping through, remembering what material is found in what chapter. We'll do more quizzing on that at a later date once we get through straight through the code for the first time. So we're on page 41, water supply and distribution. We'll see how well my voice holds up. So we'll keep it as brief as we can, but cover the information that we really need to make sure that we get covered in this, and then reviewing for your quiz. So you'll just have to bear with me if I have to pause a little bit or clear my throat. So what we've got is the scope of this chapter is this shall govern the materials, design, and installation of water supply systems, both the hot and the cold, for utilization and connection with human occupancy and habitation, and shall govern the installation of individual water supply systems. Solar energy utilization, using the sun. Existing piping used for grounding. Existing metallic water service piping used for electrical grounding shall not be replaced with non-metallic pipe or tubing until other approved means of grounding is provided. And I just ran into this just the other day. So someone had a leak in their water line out in the yard. Okay, so let's just say here is the meter box. There's the ground. Okay, here's the ground going up to the house. So there's their house. So water comes in from the water main out of the street. It comes up into the water meter, passes through a meter to where they can read how much water you're using, comes out and comes down here. And that water line feeds into the house. And then it splits off and goes all different ways and catches different things in the house, okay? Toilets and kitchen sinks and bathtubs and showers and everything else. The first thing that you have in there is a shutoff valve. Well, he realized something was wrong when he got a water bill for a couple $100. And he thought, oh my goodness, that's quite a bit more than what I'm used to paying. So he went and shut the valve off here just to make sure there wasn't something leaking in the house, a toilet running or something, and just letting water go down the drain. And he went out to the meter and lifted the cover. And if you see the meter moving at all, there's also a little indicator. If you look straight down on it, there is a big dial that goes around. But then there's also probably like a little star or a little something over on the one corner. That's the leak indicator. If you see that thing rotating at all, that shows you indication of a small leak. Well, his was leaking well enough that we could even see the big gauge was even moving a little bit there. So when we shut the water off here, this was still running, so we know it was leaking somewhere in this line. It was a lot of water, but it was finding some underground channel to take because the water wasn't raising to the surface to know exactly where it was. This was all metal, copper piping, okay? Being all metal, this is all metal piping. Inside the house, he had his meter for his electrical panel here. And then I took a look at it, and it had a grounding wire coming off of this panel and attached itself to one of these copper wires, copper water lines, okay? What it was doing is using this metal piping that goes back out and into the ground. So it was using that copper water line as a ground for the electrical panel. So what we did is we had him come in and actually what we did here is dug a new line. I didn't uncover all of this. I just uncovered it right here. And I uncovered it right in here. And I tied on and ran a new PEX line. I actually knocked a new hole through the wall, put a sleeve in, patched around it, and tied up inside the house with PEX piping. Put in a new house shutoff valve, new pressure reducing valve, make sure all that was good. But now the problem is we broke the ground. It does not. It's no longer running metal pipe out into the ground. We're running this plastic pipe out to the ground. So that does no good for grounding his electric panel. So what we did, but I still left this piece of copper stubbed through the wall, the old line that did go out to the ground. I left that in the ground. So what I did is we took a jumper wire and we jumped it from his existing copper pipe in here and used a copper jumper wire and attached it to the copper line that ran out under the ground that we left in the ground so that it could keep. So we needed that little jumper wire to make this legal, according to 601.3 in your code. All right. Let's see. And then he says, how about testing all this water piping? How do we test it? He said, wait a second. Testing and inspection sounds familiar. What chapter did we deal with that? Chapter 3, General Regulations, dealt with testing and inspection. It says 312.5. Just refers you back to chapter 3. Where is water required? Where do you have to have potable water required? Only potable water can be supplied to plumbing fixtures that are used for drinking, bathing, or culinary purposes, or for the processing of food, medical, or pharmaceutical products. Unless otherwise provided in this code, potable water should be supplied to all plumbing fixtures. Okay? It doesn't say anything about your water closets in here. So, but if you're take for your shower, for those who want to sing in the shower and open up your mouth and gargle and everything else, you're going to want, it just says you got to do that with potable water. But about 50% of your water consumption is just, just being flushing in toilets. So that does not need to be potable water. If it is potable water that you put in there, real quickly, every time you lift that lid, you're about to turn it to make it non-potable water. So it's not so important to have it in those situations. Individual water supply, where a potable public water supply is not applied, individual sources of potable water shall be supplied, shall be utilized. So if the county or the city hasn't run water down there, it just says you got to get another source of it. So you might have to get your own source of water by digging a well, providing water to it. Now it's going to be your responsibility if you got your own private source of water to do periodic testing of that water just to make sure it stays safe for drinking. All right, the size of your water service. Now we've talked about water service and we've talked about water distribution, and we'll see that again in this chapter coming up just a little bit. But the term water service is this line right here. Okay, that runs here from the meter up to a location of 5 foot outside the building wall. That is water service. From that point in is called water distribution. Okay, and all that piping inside is called water distribution. In this code, it says, what is the minimum size of this water service line? 3/4 of an inch. Minimum. All right, that's 603.1. Now it talks about this next one, 603.2. It says separating this line, not only do you have a water line coming in, but you're going to have a sewer line going out. Okay, let's just say we got a sewer line coming out. This is called building sewer. And then at 10 foot outside the building wall, it goes from building sewer to building drain. That term changes. So in this next section, it's talking about what kind of separation do you need from this building sewer line and this water service line? How much separation do we need there? If you look at it, read over it carefully. It says that you're going to need 5 foot of separation between the two. Now, if you see us, if we run one with Habitat, you're going to be like, well, wait a second. We're digging a single ditch and we're running the two together. Well, yes, there's a lot of exceptions that go with it. And some of the exceptions are dependent upon the material that you use. So let's look at some of these exceptions. It says where the water service is in the same ditch, the sewer needs to be construction of materials in 702.2. So you'd have to flip over to 702.2 and look at the chart there and find the materials. Here it is, page 60. 702.2. So if you look at that underground building drainage and vent piping, what can it be made out of? So if you look on that list, if we run in PVC a line, if we run a PVC line, then the water line can be in the same ditch as that because it's found in the list. How about a cast iron pipe? We also have the city stubs out a small piece of cast iron and wants us to attach to that. Can we run our water service in beside a cast iron? Yes, because it made the list in 702.2. This one right here. How about if it was an older style with the clay piping or terracotta, if you find that? Old Orangeburg. If you have any of that in here, you look down through, if it's some of those materials, look down and say, nope, that's not listed. So no, you cannot put it in the same ditch, same level as that. So it's got to be in those materials that are found in there. Okay. It says you could also separate them by 5 foot of dirt. As long as you got separation of 5 foot of dirt in between, you can run with that. It says when you can't, if you can't separate them with 5 foot of dirt, let's just say here comes our line running. We've got a sewer line that's running this way, and we got to run a water line, and it's got to cross here. And you say, boy, what's going to cross? So I'm not going to have 5 foot of separation. They say you got to sleeve our pipe. Got to put the pipe in a sleeve, and it's got to be a 10-foot stick of pipe, so that from the center line where it passes through, you got 5 foot on that side, and you got 5 feet on this side of sleeving that water line when you cross your sewer. If the sewer's not of approved material. And so there's another thing that you can do is you could have your sewer line down here in the bottom of the ditch, ledge your ditch off, and have the water line sitting up here, as long as you got 12 inches of separation between this one and that one. Okay, so if you can do that and have 12 inches of separation there, then you're fine. And you can notice that I measured it from the top of the pipe, the highest part of the pipe. All right. Let's see. Let you look at scan the rest of that. If you flip over to page 42, it's a table 604.3 water distribution system design criteria. Required capacity at the fixture supply pipe outlets. So on the left-hand part of the chart, it says the fixture is giving you the fixture. List the fixture over here. It will give you a minimum flow rates in a gallons per minute. And then it's going to give you a minimum flow pressure in the PSI, pounds per square inch. So let's just say it was a lavatory. Find a lavatory private. Or could have with a mixing private mixing valve. So come over here. Gallons per minute of a 0.8 gallons per minute to supply to that. And you've got to have a minimum pressure rating of 8 psi. Okay. So they're all fairly low to here, to most of your residential stuff. Now you will notice as you get higher, as you get down to here, like water closets, flush meter valves, you're going to have higher number of gallons per minute and higher pressure ratings. When we look and see and talk about how those run, how they work, you got to have a certain amount of pressure just to get that flush meter valve to shut off and quit continually running on that. And that will make more sense to you when we look at a flush valve and see the way that that's built. Okay. Always read your footnotes. If you see a little letter or something, drop down and read the footnote. Then you got 604.4 maximum flow and water consumptions. Okay. So then it takes you to another little table right here. Maximum for your lavatory private use, it shouldn't be able to flow more than 2.2 gallons per minute with a maximum of 60 psi. Okay, 2.2 gallons. So you see that those there. To the water closets, you can't have more than a 1.6 gallon per flush toilet now. Gone are the days with the 3-gallon flushes and stuff like that. I think most of your toilets now are like even 1.28 gallons per flush, but you can't buy one of the old ones. Even if you wanted to take one of the old ones and try to donate it, you can't give it away. No place is even taking them anymore unless it meets this code here. Okay. Size of the fixture supply. The fixture supply shall not terminate not more than 36 inches from the point of connection to a fixture. Okay. Let's see. So let's take a look at that. No. What's that talking about? A maximum of 36 inches. So there's your wall. Here's a fixture. Let's just make it a sink. Okay. Coming out, you got a shut-off valve. This is the supply. Okay. Coming out here, all this is water distribution piping. Okay. It's under here. You got water service, water distribution, and then you got these little fixture supplies. Now, they say this line here can't be more. It's a max of 36 inches long. Okay. Let's see. They do give an exception though. This length of restriction does not apply to residential dishwashers or ice makers. And why would that be? Well, if you think about it, or if you go look, if you got a dishwasher, more than likely here's your cabinet. You got a kitchen sink sitting over here, all right? And then you put your dishwasher in this hole. You've got to, a lot of times, if it's the water lines coming out of here and feeding up to those, you've got another one that tees off of this and comes over and connects it to the dishwasher. And you've got to be able to pull the dishwasher and slide that thing out and in and hook it. So we don't have a 36. That's going to be over 36 inches. A lot of times you'll probably get those about 5 feet long on those supply lines. Okay. Then they give you some minimum sizes of those supply lines. Another chart for you to look at. Minimum size of the water supply lines. Find your fixture. So let's just deal with that lavatory we're looking at. Find the lavatory. Come across, what's the minimum size? Oh, 3/8 of an inch. Smallest you can have on that. Let's just say, how about for a kitchen sink? Oh, kitchen sink. 1/2 inch. All right. Now you can have down here. Water supplies. Yep. Let's see, what else have you got? Service sink, showers. Shower's going to have a 1/2 inch supply to it. Water closet with a flush tank, 3/8 supply on there. Okay. Let's see what else we got. Look down to 604.8. Water pressure reducing valve. I've asked you about this one several times. So, pressure reducing valve, PRV. When do you need one? When the pressure entering the building is greater than 80 psi. So now you know where you're finding it. 604.8 is where you find that information. Okay. Service lines to sillcocks and outside hydrants and main supply risers where pressure from the mains is reduced to 80 psi or less, or individual fixtures is an exception to that. Talks about water hammer arresters. We don't need to put water hammer arresters because we're using non-metallic pipe, okay? But if you're using copper piping, hard, rigid copper piping, and you've got devices like dishwashers, clothes washers that have quick-acting little, so when it kicks the water on and then quickly shuts a little solenoid that kick the water off, and so we got water flowing through the metal pipe, but then you have something that it stops it. And you've got hard metal piping. It's called that a water hammer. When you'll hear it reverberating through them, brrr, brrr, and you hear that. Brrr, you hear it just rattling back through there. It's called water hammer. This will say, hey, if you've got those devices in, when you put those in, you got to have something that's called a water hammer arrestor to take care of that problem. Okay. Let's see. The next section is 605, materials, joints, and connections. It gives you lead content. What's an approved amount of lead for in your fittings, for in your water lines, that sort of stuff. As you go through this section, you'll see that. Water service pipe, okay? Water service. It says it gives you minimum pressure ratings. It will say you can't have not less than 160 psi at 73.4 degrees. Okay. 160 psi. Now, that's a minimum pressure rating of that, what has to be on all water service pipe. Now, if you might get into a place that's got more than 160 psi though, and if you do, you have to buy material, even though PEX might be rated for it, and just say, hey, PEX piping is good for water service. But if it's got a stamp on the side that says this is good for 160 psi at 73 or whatever, what was that? 70, yeah, 73.4 degrees. But we have more pressure. We got to find a material that's going to be suitable for the pressure that we've got. Okay. Once again, it says that water service pipe terminates 5 foot outside the building. Then it gets to 605.4 on page 44, water distribution pipe. Now, water distribution is 5 foot outside and then everything else inside. Now, water distribution pipe. Now, your water service, all they supply coming from the city is just cold water. They don't supply your hot water. They don't have a cold water line coming in and hot water. You got to heat up your own water. I have heard that people have been mixed up on that before, and they thought the hot water was coming in and that was supplied also, that they were purchasing cold water and hot water from the city. And we said, no, you've got a water heater in your house somewhere. So Anyway, so cold water is the water service. Well, when you get to water distribution, you got to have approvals for cold water lines and hot water lines. So if you look at the PEX piping, it's going to have two different things stamped on it. A certain pressure at a certain temperature for colder water, and it's going to have a certain pressure at a much higher temperature for if you got the hot water. So let's look. If you look at those, it says 100 psi at 180 degrees. Okay. And then, like the other one, like the water surface, 160 psi at 73.4 degrees. So it's the same for the cold water, 160 at 73.4, but they add a hot pressure. You got to still be able to withstand 100 psi at 180 degrees. Now, for us in the house, one, should we be at up 100 psi? No, not only on our test. When we put a test, we put on a test at 100 pounds psi, but we should be putting in a pressure reducing valve that reduces it down to a maximum of 80. And then what would be the maximum temperature? Should we be up at 180 degrees? No, we should be closer to the manufacturer, and us as an installer can't be over 120 degrees. They can crank that up. It might be up at 140 degrees. It should be the maximum allowed to come into the drainage system. But if a thermostat did stick and got carried away and was heating the water, there is a high limit switch, and those are normally set somewhere right about 180. So it needs to be able to withstand those, just in case something were to fail. You have a problem situation that your pipe shouldn't fail on you. They've got two charts here. These are all the different types of materials that you can use for water service pipe. Go across the page. Here's all the materials that you can use for water distribution pipe. You've got, flip it over, pipe fittings, different materials and approvals on them. Valves, different types of materials and approvals on them. Okay. Then you get 605.9, prohibited joints, meaning not allowed. Cement or concrete joints, joints made with fittings not approved for the specific installation. Solvent cement joints between different types of plastic. So if we had the PVC, could we glue it or solvent cement that to ABS? No, that says that's a prohibited joint. Solvent cement joints between different types of plastic. And then you got saddle type fittings that will saddle over top. And you know what? They make these fittings. They make this stuff. Just because you can buy it at your home hardware store, and it even says on the can for gluing these two different materials, for gluing PVC and ABS together, just because it says it on the can doesn't mean that it's approved by your code. And just because they sell it doesn't mean that it's an approved product that you can actually be putting in legally in your house. So it does make that a little bit confusing for you. But if you're concerned and you say, well, how do I know then? How do I know if it is? On the can or wherever you're doing it. If you're looking at this is the fitting chart. It should have these things stamped on the side here. If you do not find one of these numbers, approval numbers, stamped on the side, then it is not approved. Okay. Let's see. And then how you're going to read the rest of this? 605.10. Okay. 605.10. It's got the 0.10. Now, underneath 0.10 is going to be 0.10.1, 0.10.2, 10.3. These are all breakdowns underneath for ABS plastic pipe. So for ABS plastic pipe, how can you do joints between those? Well, you can do mechanical joints, you can do solvent cement joints, and you can do threaded joints. All of these are approved for ABS plastic. Then you got not 0.10, the next one's 0.11. 0.11 is brass. So now you're going to go 11.1, you can braze joints, 11.2 mechanical joints, 11.3 threaded joints, 0.4 welded joints. all of these fall under brass, what you can do with the brass, okay? So that's how you're reading that. When you're looking at to say, well, how can I join copper? What kind of different joints can I do between copper? Well, find copper. Oh, that's 605.13 is copper. Well, it says in 13.1, I can braze them. 13.2, I can do a mechanical joint. 13.3, I can do solder joints. 13.4, I could thread it together. And 13.5 says that I could weld them together. And it will talk you through the process, what they want to expect to see out of each one of those steps. Okay. That goes on for a couple pages for you. It gives you some location of full open valves. Some of these shutoff valves that need to be when you open it, that it will be a full open valve. Okay, so it will tell you where do you need to put them. We've got to have one for what we've always just called it the whole house shutoff valve, the main valve to cut the whole house off. Gives you some locations in here under 606.1 and then 2 gives you some locations. We've talked about those locations. Most of what you've been dealing with is like if we're doing on a crawl space, you say within what distance the crawl space door? 3 feet. Hey, this is where you find that information. It's right here. Okay. You could do it in a box located at the junction of the water service and water distribution. So within 5 foot of the building wall, you could have one there. Or you could have one in an accessible location inside the house. So if you read it, that's what that's going to tell you where you could have it. It says on the water supply pipes, every water heater got to have a shutoff valve there. Back in, you say, well, where exactly does it have to be? Well, it talks about water. Well, it's talking about water heaters. So you'd have to go to chapter 5 dealing with water heaters. And that tells you that shutoff valve needs to be located within 3 feet of the water heater on the cold water side. Okay, but this is just telling you where you got to have it. Okay, and then it goes water booster systems. I'm going to let you read down through the rest of those. Where do you have to have hot water is required? 607. It says in residential occupancies, any place that you can occupy, hot water shall be supplied to plumbing fixtures and equipment utilized for bathing, washing, culinary purposes, cleansings, laundry, or building maintenance. In non-residential occupancies, hot water may be supplied for culinary purposes, cleansing, laundry, or building maintenance purposes. So if it's a non-residential, it's not a living occupancy space. It says that you could just have a sink that's just got just cold water run to some of those sinks, because it says that the hot water or tempered water may be supplied, saying you can run it if you want to, but it doesn't say shall be supplied, meaning you have to. It just says may. Okay. Temperature controls, tempering devices, making sure that you can control the maximum outlet. I'll let you just read that. Now, here's one. The 607.2 hot or tempered water supply to fixtures. The developed length of hot or tempered water piping from the source of the hot water to the fixtures that require hot water tempered water shall not exceed 50 feet. Recirculating system piping shall be heat traced. Piping should be considered to be sources of hot or tempered water. This is considered your commercial code book. This did not make it into the North Carolina Residential Building Code plumbing section, and then that would be considered your residential section. So this particular code is only found in this book and not in your plumbing section in the residential code book. So it doesn't apply to houses. But what that is saying, your heat source you can't have something farther than 50 feet from your heat source. So if you're putting a water heater, you've got to measure it. How do you measure this when it goes along the center line of the pipe and fittings? That term is called developed length. You measure up and over along the center line and to a maximum, if that's where you're going to a maximum of 50 feet. Now it says if you run a recirculating line on this and take it off and you insulate that and you pipe it on back and go into, and that runs back and feeds back into the water heater to just make a loop again, and you insulate this line. It says that wherever you put that is considered a heat source as well. Okay. All right. Then it deals a little bit with those. Thermal expansion controls 607.3, where a storage water heater is supplied with cold water that passes through a check valve, pressure reducing valve, or backflow preventer. A thermal expansion tank shall be connected to the water heater cold water supply pipe at a point that is downstream of all check valves, pressure reducing valves, and backflow. The thermal expansion tank shall be sized in accordance with the manufacturer's instructions and so forth. Read that. So that's what we've been putting in, thermal expansion tanks. If you remember, if this is that, if let's just say that's the cold and that's the hot line. So somewhere off this cold line, let's just say this is coming in the house. You got a shutoff valve, then we put a PRV in the line. It says downstream of the PRV. So then we come off, and let's just say that feeds into the heater. Of course, we got another shutoff and then 3 foot of the heater. It says somewhere in this cold line, downstream of the PRV, we need to put that, what is that? Thermal expansion tank. And that's for every tank, storage type water heater. You're going to have a thermal expansion tank on there. All right. Protecting the potable water supply. You're going to. I'll let you read over this. It's got some signage that if you're just running something that's not potable water, you've got to label it as such as non-potable water. You've got to have means of protecting against any type of cross connection, meaning we got a source of known safe for drinking water, and we do not want to mix that with a not safe for drinking water to where it could, any type of cross contamination can happen there. Basically all your commercial stuff now has to have a means of a backflow prevention to prevent any type of feeding back. I should have saved some newspaper articles. I think it was around the Mount Airy area. They were getting traces of like fingernail particles, blood, other things that was coming into the water, and they traced it to a morgue where they were cleaning and doing washings and preparing the bodies for funerals, and they were getting a backflow from that, and it was going back through the water line out to the main line. There was cases where people have been out. They hooked the pesticides to their sprayers onto their garden hoses to where they can do their flower beds. Leaving it unattended, going inside, taking a phone call or whatever, leaving that out, and then coming back out, and then the container was empty, and thought, oh, it must have leaked out or something. Well, actually, they had gotten a backflow with a siphon in the system. You say, well, how in the world can that happen? Well, the fire department has to flush their main hydrants now and then, and they'll open that up. When they open and do that much of a flow past your line, can actually create a suction on the line, and it drew the chemicals back into the line, back into the main water main line, and a lot of the neighbors and everybody getting sick from drinking the water, just running some water from the kitchen sink and taking a drink, and they were drinking all that pesticides. So they take it of protecting the potable water really serious. So you got a lot of different means of protecting it. So read over there. Okay. Just seeing if there's anything else really important that I want you to get. I'm going to let you read those on your own. Hose connections on page 56, 608.15.4.2. Silcox hose bibs, wall hydrants, other openings with a hose connection, something you could put a hose onto. It's got to be protected by an atmospheric type or pressure type vacuum breaker, okay, or a permanently typed mounted type of vacuum breaker. If you looked at the faucets that we put on the house, okay, so it goes up to the inside. We even use the ones that got the little PEX connectors on the ends. Okay, that goes back to this plate here. What do we have? Handle on the end. This body came up and it had a little device right up on the top right here. And then it had hose thread right there, okay? What this thing is that's that vacuum breaker. It makes it meet code, and I think what it's got, a 1019 that has to be stamped on the side of that. Let's see if it does say something. It doesn't have it right here, but you should look at the numbers, and they would match up with the chart in the book on that as far as what's approved. Okay, but that's what that thing is on there. All right. Let's go through your quiz. I'm going to let you do the rest of the reading of that on your own. But let's take the last few minutes that we have to cover. This is going to actually be a 15-question quiz, making you step up your game a little bit. But it's going to be a true or false, so a 50-50 chance. Question number 1. Can you run? It says non-potable water cannot be run to a tub. Non-potable water cannot be run to a tub. Is that a true or false statement? Potable, meaning safe for drinking. Non-potable, not safe for drinking. It says non-potable cannot be taken to a tub. Is that true or false? Okay, I'm going to let you look for the information on these on your own. Just go back. We did cover that in the video. So most of this stuff we should have covered. You can either go back and watch the video to try to pick up on it after you write down these questions and try to listen for it again, or you can go through your book and try to locate these answers. Question 2. The minimum size of the water service, the pipe, is 3/4 of an inch. The minimum size of the water service is 3/4 of an inch. Is that true or false? Number 3, the water service can be in the same ditch as the sewer line. Is it possible? Now, is it possible? I'm not asking you, is it that it stands firm every time, but is it possible to have the water service in the same ditch as a sewer line? True or false? Question 4. A PRV is needed when the water pressure entering the building exceeds 80 psi. Is that a true or false statement? You need to put a PRV in when the water pressure entering the building is greater than 80 psi. Question 5. The maximum length of the fixture supply line is 36 inches. Maximum length of the fixture supply is 36 inches. True or false? Question 6. The minimum size fixture supply to a lavatory is 3/8 of an inch. Minimum size fixture supply to the lavatory is 3/8 of an inch. True or false? Question 7. The minimum pressure rating on water service. Minimum pressure rating on the water surface is 160 psi at 73.4 degrees. Is that 160 psi at 73.4 degrees? True or false? Water surface. Question 8. You cannot solvent cement ABS to PVC. You're not allowed to solvent cement ABS to PVC. Is that a true or false statement? Saying that you cannot solvent cement the two together. Question 9. 5 steps to a solder joint is cut, ream, clean, flux, and then solder. Your steps. So if you were looking for this, go back into that section. Remember what I was covering and saying, oh, find, what are we telling me? Steps to a solder joint. So probably under copper piping. How can you join copper piping? Look at it, and one of them is going to say soldering. And then under solder, look and see what the steps are to solder it. Does it say cut the pipe, ream the pipe, clean it, flux, and solder? Okay. If it has those things mentioned, then that would be a true statement. Okay. Question 10. You can attach copper tubing to galvanized steel pipe with a brass fitting. All right, is that true or false? That you can attach copper tubing to galvanized steel pipe with a brass fitting. And look for one of the main typos. I think even underneath there, it'll say it's going to talk about joining all the different pipes, and it's about 4 different pages there, the stuff you got to fit. But look at one of the main titles, and it will talk about attaching copper tubing to galvanized steel pipe. And is one of the options, as you read under there, can you attach it using a brass fitting? Is that possible? Okay, true or false? Question 11. The whole house shutoff in a crawl space, it needs to be within 3 foot of the crawl space door. That shutoff valve in a crawl space is going to be within 3 foot of the crawl space door. Is that true or false? Question 12. A vacuum breaker must be installed 6 inches above the flood level rim of the fixture or device. All right, the vacuum breaker must be installed 6 inches above the flood level rim of the fixture or device. Is that true or false? Just as a note, here's some places you can look. 608.13.6 or 608.15.4. Okay. Use those. Question 13. Vacuum breaker is not allowed to be installed under an exhaust hood. Is that true or false? The vacuum breaker is not allowed to be installed under a exhaust hood. True or false? Once again, look at 608.15.4 to find that answer. Question 14. How you measure the air gap is from the lowest end of the potable water outlet to the flood level rim. How you're measuring air gap as it relates to the water supply and distribution system here. Sink, top. The lowest end of the fixture outlet to the flood level rim, the edge where the water is going to come out. Okay, that's the flood level rim, FLR right there. Between the fixture outlet and the flood level rim, air gap. That is, I'm going to go out. We didn't talk about it, but that is how you measure that. That would be a true statement. But I just want to show you a picture so you can kind of picture it in your mind. As it relates to the water supply distribution system, that is how you'd measure that air gap. Let's see. And your last one, question 15. Let's see. Non-potable distribution piping needs to have pipe identification every 25 feet. If you got for non-potable distribution piping, you need to have pipe identification every 25 feet. Is that a true or false statement? Oh, I would look around 608.8.2, 608.8.2 to try to find that, to see is the spacing on for the pipe identification every 25 feet on that non-potable water, non-potable distribution piping. Okay. Take your time, go back through, look those up, read the blanks, sections that I didn't cover, and you'll be set. And you'll be ready for that quiz. So make sure to anytime now after this you can log in, take that chapter 6 quiz. Hope you have a great rest of your day, and I'll look forward to seeing you next time.